holding or putting something in a container which is not easily breakable. The term encapsulation was derived from the normal life situation whereby you find that when you buy medicine, they are mainly put in capsules. And the capsules inside is where we have the real medicine. And the reason for this is to prevent the medicine from interference from the outside world. That is where the word came from, as far as we are talking about the normal life situation, layman language. But when it comes to programming, now when you talk about encapsulation, I would like you to know that you should know, or you should think, what should come in your mind is what we call a class. Meaning that whenever you write a program, and in that program there are classes, you are actually implementing encapsulation without your knowledge. By defining variables in a class and putting them in different access specifiers, for example, putting them in private, putting them in protected, putting them in public, somehow you are actually doing what you call encapsulation. In other words, these variables of this class, they cannot directly be accessed by other classes. If I can give you an example, you declare variables in the superclass, and then you have subclasses that will like use those variables. By declaring them in the superclass, by actually putting them in the superclass, you are actually ensuring that they are safe. And indeed, by putting them in private, protected, majorly, it means that they cannot easily be found. And indeed, in private, it's very rare for the variables to be accessed. In protected, there must be permission for them to be used by other variables, sorry, other classes. So basically what I want you to get is that the term encapsulation is associated with putting variables in one class. Like now when you say class A, and then you proceed in that class, you go down and say private int A, protected int B, public int C. So you are trying to hide these particular variables in different access specifiers. You are actually implementing encapsulation. I don't know whether I'm making sense in this explanation. You see, I'm not even reading the content that I've displayed. I wanted to first to explain so that you can be able to get the meaning at a glance without thinking further. That when you hear the word encapsulation, you should know that this is actually when you create a class in a program, and in that program, you declare variables in different access specifiers. Then, if now I can read what we have here, we are saying encapsulation is a process of combining data members, class data members, and I would like this to be clear to you. These are variables, for example. Then functions. Functions are the one that we normally use to be able to access those variables in a single unit called class. This is to prevent the access of the data directly. The access to them is provided through the functions of the class. It is one of the popular features that helps data hiding. Actually, this is an explanation, a first definition. And if you look at this definition, you can simply sum it up and say a simple putting of data members and functions in a class is what we refer to as encapsulation. A second definition, we are saying a data encapsulation refers to the process of binding together data and functions or methods operating on this data into a single unit. And then we are saying so that it is protected from outside interference and misuse. Class outside interference and misuse is actually other classes. Like now we have superclass A, and then superclass A may be having subclass B, and subclass B tries to access variables from superclass A. That becomes, there is always that kind of protection within class A, which is a superclass, and the variables are protected because they are put in a class and in the different access specifiers. All right, then we are saying this is an important object-oriented programming concept, and it leads to yet another OOP concept known as data hiding. Brothers and sisters, the meaning of data hiding is when you put variables in an access specifier which is called private. You're hiding them from other classes, or what you call protected. You are also hiding, but to a certain percentage. Then also we'll be talking about the data abstraction later as we continue learning. I don't want to mix you with the two. They are almost similar. But there is some bit of small differences between the two. And we are saying encapsulation hides data and its members while abstraction exposes only the necessary details or the interface to the outside world. So data abstraction is like your hands. Let me talk about your hands. When you want to greet somebody, you have to stretch your hand. I believe this is clear. Then somebody will also stretch his or her hand, and then you greet each other. The same case applies in now for classes to exchange data. Normally, these variables that are going to be exchanged from one class to another, they must be away. They are going to be brought in. And normally, you normally use what you call, what we refer to as a inheritance, using either what we call public mode inheritance, or we can also use functions that are within the class. So the functions and the mode of inheritance are actually the ants that actually implement abstraction. So abstraction is like giving out. We'll talk about that one in a moment as we proceed so that we can get. But now we are concentrating on encapsulation. So in the real life situation, here we are talking about the capsules. This is just a normal situation. Remember again, we can trick you. We'll ask you a simple question. Explain the real life example of encapsulation. In this case, we don't mean you are talking about the code, but you're talking simply about the life situation of a normal state. That's just a layman question. But it's important that you know that encapsulation in C++ is implemented by the use of classes. And actually, encapsulation is the hiding of variables that are within that particular class. Then the benefits of encapsulation, it provides abstraction between an object and its clients. This is a technical explanation. What do we mean by provision of abstraction between an object and its client? If I say class, that, for example, Matthew, I'm abstract to you. Richard, I'm abstract to you. Evans, I am abstract to you. Grace, I'm abstract to you. Anne, I'm abstract. It means you don't know much about me. Maybe you only know my name, but you don't know much about me. The same case applies to me on that side. The same analogy is the one that is used in when classes are exchanging data. Class B is inheriting integer x from class A. But in class A, we have even functions. So the only thing that class B will get from class A is that integer x. The rest of class A, class B does not know. So that is what we call abstraction. Only having small information about a particular class, a superclass, for example, here the object will be a superclass, and then the subclasses will only know X because they're inheriting X, but they don't know whether class A has functions and many other data members. That's what we mean by abstraction. I hope I'm clear on that point. It protects an object from unwanted access by client. Yes. For example, we talk about a scenario whereby a class is trying to, a class which is a subclass or a child class is trying to inherit from a parent class on the private access specifier. It will not be allowed. It won't be allowed because the private is not accessed, is not inherited from the superclass. I hope this is clear. Then finally, we are talking in a live situation application. For example, in a system that run our world, whether it's in hospital, whether it's in an institution of higher learning, whether it is in banking sector, there are some things that one can do and the other things you cannot do. For example, you'll find a system that is in a bank that you can be able to check your balance, but you cannot be able to change your balance because you are a customer. And this is possible because changing of the account balance is just been hidden from you. And that programming concept of that system, you can't know. You only get the abstract part, seeing your account balance. You don't get how to change it. I hope that I've shed some light on this explanation. Kindly, before I proceed, let me know whether each and every of us, one of us here, has really understood the meaning of encapsulation. Somehow, to a certain extent. I will appreciate it. Just confirm on the public chat before I proceed. I really appreciate that. And if you have any question, post it there so that we can be able to continue. Okay, good, Grace. I understood. What about Evans, Matthew, Richard, and Anne? Please confirm very fast so that we can proceed. Whether you have understood the explanation. The reason why I decided to explain from this end is for the purpose of understandability. Kindly confirm. Let us be fast in confirmation. I don't know whether you have a challenge in typing. Okay, so that okay, Richard understood. What about Evans, Matthew, and Anne? Please let me hear from you. Yes, Kelvin, welcome. Okay, good, Anne. Good, Matthew. Kelvin, you have to catch up. I think you are still connecting. I believe you will be getting us as we continue. Okay, now that I've explained, in fact, what I was explaining initially is what is in the second slide. So you should not be worried. What are you saying here? So this is just letting you know that when you declare variables in a superclass in the public sector, they are accessible by the outside world. Remember here, class, the outside world is actually the other subclasses. The same case applies that when you declare variables at protected section of your class, they can be accessed by the outside world. And remember again, we are talking about derived classes. Derived classes. For public, even other classes can access. Even the main function can access. But now when it comes to protected, only derived classes that are inheriting using different modes of inheritance can be able to access this particular data. But when you declare variables in the private, they will never be accessed. They are just private to that particular class. So inheritance cannot be implemented under private access specifier. So in action, that is how encapsulation is actually implemented. Declaring variables in the private, you are actually encapsulating them further. Okay? So here we are saying that the public, protected, and private normally are used to represent encapsulation. All right. Another thing I would like to mention here, let me go through this after explaining. A class in C++ is the one where we bundle together data members and the functions operating on those on these data members alongside with access specifiers like private, public, and protected. And these represent encapsulation. Then the other point is that we also know that the default class members are private. What does this mean, class? Whenever you declare variables in a superclass, I hope you are getting this. Whenever you declare variables in a superclass and then you don't actually put, for example, you don't put public, you don't put protected, you don't put private, the system or the compiler will take those particular variables as actually private. So when you declare without stating the access specifier, you should know those variables that are declared without using the access specifier, they are all private to that part class. So the default setting is that if you don't put any public, sorry, any access specifier, all those that have been declared there in the class will be taken to be private. That's the meaning for that by default, the original setting. And then we are saying that when you declare members, and remember again, members here are variables as private, and a method to access the class members as public, we are truly implementing encapsulation. This is a very technical point, but very, very important. Allow me to read it again. When you declare class members, and the class, I want you to know that the class members here are variables. I can even change this term and say, when we declare class variables as private, and the methods to access the class members as public, what are the methods? The functions. The functions. The functions here are the ones that are normally used to take data into the main function and the class. I remember when I was talking about inheritance, I was showing you that the functions normally communicate between the variables and the main function. So the functions are what we call the methods, and then we are saying that when declare class variables as private and then declare functions to access class members as public, we are solely implementing encapsulation. Maybe I stop here and then I go back to the program so that you can get this. I think I need to talk about the program. Now look at this program. Class, are you able to see confirm to me so that I can explain that particular point? Are you able to see this program? I want to use that program to explain the concept that we are talking about, which is very important. Are you seeing it, class? One of you to confirm so that I can be able to talk about encapsulation, how is it being implemented here. I hope you are seeing. One of you to confirm very fast whether you are seeing this code so that I can proceed with it. And remember, these notes are with you. These notes are with you. These notes are with you. Always try to read them. Is it visible now? Is it visible? Yes, Richard, I think I've zoomed. I think now you can be able to see it. Okay. Now, look here. I want you to be very okay and understanding what we mean by encapsulation. We have said in our statement, when we declare data members or class variables or class members as private. Like now, in this class called sum, we have our class members. And the class members include A, B, C. And the class members actually here, to be more clearer to you, these are just variables. These variables A, B, C have been declared in the private or access specifier of class sum. Now, for them to be accessed by the outside world, they can only be accessed using a function. Void add is a function. Void add, the term void means this function is not doing any calculation, it's just picking data. The void add is a function or a method, and this is the one the int main function will talk to and ask this particular function please can you provide for me these variables that are here. So these variables are hidden and they can only be accessed by the function in the public, which is add, if int main wants to access these variables. So int main, if it wants to access these variables, it will come here and seek the add, ask for permission. The add will come and pick them and then deliver them to the int main. I'll be talking about this program as we proceed, but I wanted you to understand the meaning of what I mentioned here, what I was talking about here. So that when we declare class members as private and method to access as class members as public, we are implementing an encapsulation. And I said this can be changed and be paraphrased as follows. When we declare class variables as private and a function to access the class members as public, we are truly implementing encapsulation. If I go there again, our class members, our class variables are in the private, and our method or function that is going to give them to the outside world, which is void add, is in public. And this is what we call an encapsulation. Please, can you confirm to me whether you have understood that explanation before I proceed? Kindly confirm. One of you to confirm whether you have understood. Remember, here is a matter of understanding. We are not cramming anything. It's a matter of understanding. Once you understand the concept, it will remain in your mind. It will remain in your head forever. Richard is very categorical. Is okay. So what about the rest? If you have a challenge, don't shy. I will always repeat. I will always repeat. Don't shy and keep quiet. Okay, Doreen is requesting for a repeat. It's okay. Okay. Our class, we are talking about that encapsulation, and we have simply said that encapsulation is a feature in object-oriented programming languages. The languages that normally support encapsulation include languages like C++, Java, Delphi, Pascal, Visual Basic.NET, etc. For this particular session, you are using C++, and we are trying to unfold or to get how C++ implements what we call encapsulation. We have simply said that when we write a program, and in that program we incorporate classes, we are actually implementing encapsulation without our knowledge. And then when we go further in our classes and insert or place 3 access specifiers or 2, which include private, public, protected, and then in these particular access specifiers, we place their variables and the functions. We are actually implementing encapsulation. But that's not the end. That's not the end, because if we talk about that scenario, it will look like it's a theory explanation, but we needed to understand how in a program is this achievable. And indeed, that's why I was keen going to the program and explaining how this encapsulation has been implemented. In this particular program that I'll be explaining later, I only wanted to first to say, when I look at it at a glance, I can see we have class sum. Automatically, I will know that there is encapsulation in this program because of the term class sum. Just simple. That is the first step. Then when I look critically on the program, I see there is also an access specifier called private. And then also there's another access specifier called public. Then I know there is further implementation of the encapsulation. Then, when I look keenly and I get that in the private, I've declared variables in the private sector. Definitely, I've done what you call encapsulation. These particular variables cannot be accessed by other objects. By that we mean by other classes, subclasses, or the main function. And for them to be accessed, there must be a function. And the function must be placed in the public sector. Remember, we normally use two terms interchangeably. Method and function, they mean the same thing. Now the function in this case is called void add, and for your information, this is how you create a function. This is the syntax void add, meaning that this particular term void means that it's not going to do calculation, it's only going to present data, but calculation it's not going to do that. All right. Then in this particular state, void add, we simply say that this is the one which will be communicating between the main function and this class, so that at the end of the day, these variables would be found and be given to the int main. So this is like an AND of class sum, which is in public. And this AND is going to be used to communicate with the main function and vice versa for it to access these particular variables declared in the private. And this is what you call encapsulation. A, B, C have been encapsulated in the private sector of class sum, and function add is now used to enable the main function to access those variables. Am I clear to that level? Kindly confirm. Kindly confirm. I will appreciate. Am I now clear? Is it understood before we proceed? Is it understood? Kindly. You see, I'm taking time because I know this is a very important concept which requires a bit of understanding, not cramming. Kindly, class, don't cram, just understand. We shall be very happy. Okay, that's good. I can see the confirmation from Doreen that things are okay, and we can now proceed. Okay, having explained that, and having given you such kind of explanation, I'm believing from this side and having that we are actually doing fine, and we need to proceed. Now it will require me to go direct to the program so that you can now be able to get it clearly. Okay, now let me proceed from here. At the same time, we provide abstract view of data to the outside world in form of public methods. Again, the word abstract has come. And remember saying that when I say that I'm abstract to you, it means you don't know much about me. You only know my name maybe, and nothing else. The same case applies. When we say that a class is abstract to the other classes, it means that that class, which is a superclass, can only provide the required variables that are being asked from other classes. For example, if I go back to the program, this particular program, and I want you to be keen on the understanding the term abstract. If you look at this particular program, this void hard is the one that is going to provide what you call abstraction. For your information, the int main function is only saying void hard of class sum and is not saying these particular variables. That means void hard on public provide abstraction. It can only be seen by the int main. The int main does not even understand whether class A, class sum has these variables, because they are in the private. So abstraction normally is given out in the public access specifier, and abstraction is normally giving out what is essential. Let me give you a good example. We'll be talking about abstraction. If you're having your mobile phone, you simply touch your screen. Maybe you talk about the smartphone, and then when you touch the screen, you're able to open and be able to actually access the numbers. But you don't know much about the phone inside. You only get the abstract, the interface, but the inside part of the phone, which has been encapsulated, you don't know how it functions. And this is what we refer to as actually abstraction. I don't know whether I'm making sense in this explanation by trying to get you understand the meaning of abstract, that at the same time we provide an abstract view of data to the outside world, and in this case in the form of public methods, public functions or methods. So the public one will be seeing the public functions, but they cannot see the variables declared on the private. Am I making sense, class? Am I making sense? Am I making sense? Can we confirm, one of you? At least I'm sampling so that I can proceed on the side of abstract. All right. Thank you, Narisha. Using one sampling allows me to proceed, because we always say that any content displayed to learners must be clarified. You cannot tell learners just read, and then you give them the exam in programming. That is not programming. That is a theoretical unit which requires reading only. But in programming, anything you present to your learners or any panel must be understood, and it must be fully understood. Now, again, let's look at this particular explanation. It's actually meant to make you really understand what is encapsulation and how does it get related to what we call abstraction. The methods or functions are declared as public and can be accessed using the object of the class. This is actually a repetition of what we have said, that for example, in that program I was just showing you, simple, the void add function has been declared in the public. Then, however, we cannot directly access private members. Very true. And this is called data hiding. Those particular variables A, B, C, they are already put in private access specifier, so they cannot be accessed by the outside world, and hence they are being hidden. And hence the process is called data hiding. When this is done, data is secured and can be accessed only by functions of that particular class in which the data is declared. Very true. That's what you have seen here. If you go back to our scenario, these particular variables can only be accessed by this function, and they can be given by implemented by the int main, which is the main function. The only communication can only be through void add, and the void add is the only one that can access these particular variables. Hence, there is what we call high level of encapsulation. Okay, this diagram is just an explanation. Private int ABC, this shows that there's encapsulation or hiding of the variables. And then we have class instant object is used to communication between the class and the main function. This one requires me to explain now the entire program so that you can see how this program is behaving before I went up on this particular point. Sorry for this. It's just a pop-up. You know, I'm connected to the internet, so such kind of interference can always come. Now, let me go through this program very fast so that I can make you get the concept and feel at home in terms of when you talk about encapsulation. So in this class, in this particular program, we have our preprocessor directive with the input-output stream header file. You also have this channel includes another directive for the input-output header file. This one comes in because Normally, the keyword clear screen and the get character, the meaning is found here in this class. So if you don't include this particular header and then you use this particular clear screen, remember you clear the screen when the program runs so that you can only have what you want from the program. Definitely there will be a syntax error because the compiler will be complaining, I don't know the meaning for this and that. So after that, we said after declaring the headers in your program, the next thing, if your program has classes, what start first the class? So for us to start a class, we normally use the keyword class sum. Then we open the body of our class. Then in our class, we declare variables in our private access specifier, and we declare private full colon int a, b, and c semicolon, meaning that these particular variables are already hidden. And if I was keen, I'll know that this is encapsulation that has just started. These particular variables are hidden from the outside world. Then I have another access specifier called public. Now, when I get this one, then I'll know this is abstraction that has come in. And abstraction means that this function is going to provide the link between any other classes or the main function, so that this particular function can be able to give out or supply the hidden variables to the outside world. So normally abstraction means that the outside world would only be seeing void add. If int main was looking at this class sum, it won't be seeing this. It's only seeing void add, and that's the meaning for what we refer to as abstraction. Then note, you can see a function also must have a body. Then void add, we open the body of the function with a normal curly bracket, and you can see it's being closed here. It's being closed here. You open and close. And if you cannot, the body of a function normally is not close to the semicolon. The body of the function is not always close to the semicolon. Either it's a main function or any other user-defined function. Like now the add one, we don't close them with them. The only thing that is close to the semicolon is actually the classes. The classes are terminated by the semicolons. You should be aware of that. Then inside the body of the class, we ask the user to be able to enter. We ask the user to be able to enter any two numbers, and then these numbers will be taken in. So see out, enter any two numbers. Then these numbers will be taken to the computer RAM, and the syntax in, we normally use the keyword cin, whereby we have this kind of insertion operator, and then we have a, and again we can have this kind of syntax. Instead of repeating cin, we can concatenate our insertion operators and then have the next variable. So the two variables will be asked. So the cursor will remain until you enter two values, which are numbers. Then we compute the result of the two by addition of a and b, and we store it in variable c. And then again, finally, we display our result. We simply display our result, and the syntax is sum. We can even see out in full extraction operator. Then we normally say full colon. Here we can write any language because we are communicating. You can say sum is or sum full colon. Then use the variable that we computed. Again, look here. We are actually concatenating this and this with this particular C out currently being used, or function that is being the defined function here. Then we simply use the variable that we use for the purpose of computation, and then we close our class. And then finally, we close our function, the add function, and then finally we simply do what we close our class. Now, for the program to be complete, the main function must come in, because the main function is the one that's going to take the value. Then, for this to happen, we open the main function by saying int main, opening and closing bracket. Then we open the body of the main function. Then we now create what we call an instant variable or what we refer to as an object variable, or what we call known as to us what we call a class variable. In this case, we are talking about sum. For this particular int main to be able to communicate with this class sum, it normally uses what we call an object variable. So we said initially that to create an object variable, you pick the name of that particular, class, and then you put a space, and then you give an identifier. Like in this case, we are saying sum space s. So s becomes an object variable for class sum, and there is the one that is going to be used by this main function to communicate between the class and itself. So look here, see how now the communication come in. So use that object now, c dot add an opening and a closing. Simple. The main function is actually calling the function add. The main function is calling the function add, and you can see the method is very simple. Use the variable that has been created for that class, full colon, then put in the function that is within that class, and you simply write it with the opening and closing bracket, so you avoid the word void. So we are telling, in fact, what the main function is saying, please can you do what is in you and provide me the answer. This is like, this is a worker and this is actually the supervisor. And then get character, this is a function that is normally used to display anything that has been computed and is residing in the computer memory, so that it can now be able to be displayed on the computer screen. As simple as that, we have done what we call encapsulation of data, and we are using abstraction. Class function add is being called the main function using an object of class sum, and the method is s.add, and then eventually is like the entire this one will be coming here, and the main function is going to display for us the result of this particular class. I believe I've done a lot of justice in this explanation, and remember again, programming is very technical. I accept the variety deviations of our understanding, because that's how programming is. Programming requires a lot of time to internalize. But from this explanation, I don't know whether I put some justice to you. I don't know whether each and every person has understood in his or her own angle a certain percentage, so that I'll really be okay in relation to encapsulation. I'll be very fine on that. Okay, clear screen. Natasha is asking, this particular keyword in this acronym in full is called clear screen. You know what happens is that whenever you do the output on a computer system, always the operating system in what we refer to as a DOS environment, the one which is black and white, it might be having some information. So we want, when the program runs, we'll clear any operating system information that are on that screen, and we only get enter and two numbers. So this is for the purpose of clearing the screen for outputting purposes, so that we don't have any other information on that screen. I don't know if that made some sense to you, Naresha. Please confirm so that we can proceed. Kindly, I need your confirmation so that we can proceed. I need your confirmation. Kindly, I really want to know whether we are doing fine on encapsulation. It's very well. Richard, can you speak? Yes.
Okay, I have a question.
Please ask.
In other functions like okay, kama hapa kwa encapsulation naona main function inakuja huku chini na programs zingine nilikuwa tunaona ikikuja huku juu.
Okay, okay. Yeah. Let me answer that one. I want to say the following, and I believe all of us, Richard is asking that in other programs you have been seeing that the it main has always been coming up here, and for this one, the main function is coming downwards. So he's actually wondering what's happening here, and yet this is our main function. How can be a main function be below? For your information, according to the syntax of C++, when writing programs, classes, the program that has classes must start first. The classes must start first. Here is okay. In analogy, I can put it in a way that, let's say, for example, you are going for a meeting, and maybe you're going to meet your manager where you're working. What happens is that the workers will come first and they settle down, and the manager comes later. The same analogy is the one that has been used in C++ concept in the relation to writing a program that has classes. Classes must start first. After all the classes have been written, then the main function comes in to now control and coordinate and direct those classes. And that is the syntax. I don't know whether I'm making any sense to you. Richard, can you confirm whether you have understood that? It's as plain as that. That classes must start first and then followed by the main function.
Yes.
Okay, thank you. Now, any other clarification? Another clarification? Can I assume that you've understood by 0.001 or by 1% or something or 10%? Can I assume that, class, so that we can proceed? Kindly, about 3 of you to confirm so that I can be able to continue. Or should I mention your names again? I'm starting the way you are appearing here. We have Anne, Kelvin, Erica, Doreen, Grace. You also have, listen, only, I think I need to check this one. This is, we have Martin, we have Matthew and Rasha, Richard and Vanessa. Please kindly confirm whether you have done something. You see, I am not living here. I'm not living here until you tell me whether you are okay on this particular scenario of encapsulation. Kindly confirm. At least 3 of you so that I can be able to proceed. Okay, well done, Martin. I think you said you've confirmed. Okay, well done, Risha. And also somebody else again, one of you to redeem us, proceed. All right. Aha, Doreen, I can see you're typing. Okay. Okay. Eric also is typing. All right. Now, that's very fine. I think we're doing well. We're doing great. I'm happy that we are trying to understand this concept, which is very okay. I wanted to talk about abstraction. And you can see now here, I'm showing you a diagram of a phone, which I was initially saying. I will be very short, precise, and clear. In a real life situation, when you touch your phone, the phone normally gives you the interfaces in form of the icons, the graphical representation of parts of your phones, where you can access your phone contacts, where you can access your camera, etc. That's what we mean by abstraction. But if you open the phone inside, you will find so many physical components that are actually encapsulated, which you don't know the meaning, which you cannot. In fact, abstraction for information, it is the operating system interface. And in this case, we are talking about Android interface. I believe you are doing mobile programming, and if you are doing that, you don't know what's Android programming. So the interface is the abstraction, but the hardware is the encapsulation. That's as far as what we call the real life situation is. And if you are keen, you realize that in our explanation is like I've already spoken what we mean by abstraction. And I want to be very clear on this. Abstraction is when in a program we have classes and the variables are declared in the private sector of the class, and then a function is declared in the public sector, and that function is the one that communicates between that particular class and the main function or other subclasses. And truly, that shows what we refer to as abstraction. In other words, that abstraction is only providing to the outside world what you want them to see. In other words, a class, if it wants variables to be seen by other classes, they must be declared in public. If a class wants the variables to be private and only provided by the use of function, then they should be put in private, but in the function, in the public sector of that class, we must have a function that is going to supply the communication. And indeed, that shows the abstraction level. Then here we are saying data abstraction is a concept of object-oriented programming that helps us to represent only important features on the program without including this background details or explanation. In this particular example, class sum is abstract to main function int main, and is only providing essential information or required information by class main. And in this case, class main is only seeking for the function add, so the class main can only be able to see void add, but it will never see the background of the sum, and that we mean it can never see A, B, C. So A, B, C are hidden. So when main is trying to look at sum class, it can only be seeing the void class only. And that's what we mean by the term abstraction. So class sum is only providing void add, which is in the public, but the hidden part of it is not being seen because of it has been declared in the private of that class sum. So I believe this explanation is further understood, and it makes sense to you by this explanation that it is an important feature of whereby the program feature of the program without which actually, let me go through it again. Data abstraction is a concept of object-oriented programming that helps us to represent only the important features of the program without including this background details and explanation. I believe with that explanation, you have seen data abstraction. So sometimes they do go hand in hand together. They go hand in hand together. Maybe when I talk about the phone, this is what I talked about, the initial state. And the smartphone, you know what this does, but you may not know how it does or what it does. You only care about the display screen and the keyboard buttons rather than worrying about the inner circuitry. Here, smartphone is an abstract where the inner implementation design are encapsulated. So this is a normal life situation of explaining encapsulation, or sorry, a data abstraction. So when you look at the program, I decided to use this program to further enable you understand. I believe that this program currently is visible, and if it's visible, you can allow me to explain it, and so that we can wind up on this session of what we refer to as data abstraction. Now, we have our first header file, channeling good EO stream. We have our library using name standard. Then we decide to have a class called class summation. Then we open the body of the class. Then we declare our private members. Again, the same, almost the same. We declare our private members, whereby we have private, we have int A, B, and C. Then we have our function in the public sector of the class summation. We have a function called void sum, and the void sum will be used for actually getting the communication and having the competition. Then here in void sum, we open a bracket and we declare two, what we refer to as two variables, int x and int y, and we normally call this one, they are normally called parameters. They are called parameters, and to make you understand further, they are actually what we call they are communication variables between class sums, the function sum and any other function. For your information, these two variables are going to be used for data exchanging between the main function and the sum function. And in this case, these are the two arms. And I want to explain in a very simple way so that you can understand. Like you are spreading your two hands to somebody, asking that somebody to place on your hands something you need or two things you need. The same case applies. That for us to get data from the main function, we are going to be using these two variables. And these two variables, they are the only one, x and y, that can be seen by our main function. And these two variables, x and y, are the ones that are going to be used to exchange data into our private variables here that are not seen by the other one. Then what happens? We proceed. I'll be coming to this. Because now, if I don't come here first, you will not be able to get what is happening here. Now, I've said in the public, we have a function called void sum, and it has two variables that are going to be used for communication, and we are calling them parameters. They are just like two ants. One is called int y and int x and int y. They are integers because they are going to get values which are integers from the main function. I stop there. I come to the main function. In the main function, then I declare, I open the body, int main, I open the body, and then create what we call an object variable for class summation. Object variable for class summation, call s. Then I use it to communicate with the function sum. I use it to communicate with the function what? Sum. By doing the following, s.sum. Then in the process of communicating, I supply two values, 5 and 4. Meaning that when I'm communicating this one, I'm accessing this particular sum, I'm going along with it 5 and 4. So 5 and 4 will be placed here. Right? Then they'll come down. Now, currently we have 5 and 4. Then we open this body of the sum function, then we do the calculation. Now, this private variable will be used to store the value of x, which in this case is 5. Then this variable b, which is in private, will be used to store the value of y, which is 4 at the moment. And then c will now be used to compute the value of a and b, which is equals c is equals a and b, meaning that the 5 and the 4 have now been placed here by this particular computation. So it will be actually 5 and 4. And then now we'll be able to display the size. See how sum of the two numbers is. Then we have the c, and then we take the cursor downwards. And then indeed, at the end of the day, our answer will be able to be 9, because this will be 5 plus 4. And then we end the body of our main function. Then we end the body of the class. And finally, we are going to return 0, meaning that our program in the main function has completed successfully. Then we stop. Such simple scenario gives us this particular answer. And how as abstraction being shown. These particular variables have been declared in private. This particular function has been declared in public for the class summation. and it has been used to get values from the main function using the class objects s of summation, and then these two numbers are taken in from the main function to this particular sum function and placed in x and y, and then when they are placed here, the x and y has been used now to access the private sector, whereby a has taken the value of x, b has taken the value of y, and then c does the computation of a and b, and then finally c out. The sum of the numbers is c, and then we end the body of the function, we end the body of our class, and then finally we stop. Such kind of scenario is with what we refer to as abstraction, whereby this is where the level of abstraction has come in. And indeed, main is only seeing void sum, and main does not know about whether we have a, b, c. But you see, a, b, c have been used for computation. I believe I'm good to that level. Please confirm whether you've understood something again so that we can now proceed. Remember again, kindly download this recorded video. Make sure you download it. After some time, it will be there. You can download it and rewind and listen to it. It will actually serve your purpose very well if you can be able to listen to it later. Okay. May I say that somehow, at least you have an overview of abstraction and encapsulation. Can I say that? Class, can I say that you're okay? Remember again, we need more reading. Keep on reading those notes. And then allow me to do something very fast within 10 minutes. Okay. What is the main difference between two? Aha. I want you to know that encapsulation is hiding. Encapsulation is hiding. Like now here, private, int A, B, C, we are actually encapsulating this. Abstraction, that abstraction is providing to the outside world. Like now, in the public, void sum int x and int y is the abstraction level. In other words, this is the only thing the main function can see. Are we there? Natasha, are we there? I believe I'm clear on that. That encapsulation means hiding. Abstraction is only providing what is required. And whenever you want to provide that, it must be declared in the public sector of the class. Like now, encapsulation, that abstraction is associated with the provision of placing what you call functions on the public sector of the class for the purpose of communication between the class and the main function. I believe I've shed some light on that. Please note that. Now, class, let me talk about polymorphism, and then we'll stop here. I'll take about 10 minutes talking about polymorphism, and then we shall stop there. Mm-hmm. Okay, class, let me briefly talk about another feature of object-oriented programming called polymorphism. For information, polymorphism is, I think, a Latin term or Greek one that it means, normally it means a representation of different forms. If I can give you an example, the meaning of polymorphism, like if we talk about sound, normally human beings we talk or we speak. Other animals, like the birds, have their own way of communicating, which is known. Dogs have their own way of communication. Actually, different types of animal. So here we are talking about a particular class of animal, but representing their way of talking in different ways. The same analogy is also incorporated in programming. In other words, functions within classes can behave differently. Depending on the state they are in. Operators like addition, subtraction can give you different results. Let me take, for example, an operator which is an addition. If I say 1 plus 2, I'll get 3. And if I say 1.0 plus 2.0, I'll get 3.0. So here, however much you're looking at the answers and you're looking at them to be the same, but critically, we will analyze these two answers, they are different. One is 3, another one is actually 3.0. One is an old number, another one as a decimal number. So the ability of the operator, which is a minus here, to be able to give you result for whole numbers and actually give another result for decimal numbers, that in itself is what we call polymorphism. And in this case, we are talking about a term we refer to as operators overloading. What does that mean? The operator here is the addition sign. And overloading means that this operator can give you result for whole numbers. And at the same time, if this operator is given decimal number, still it can give you the result of decimal numbers. Hence, it is actually exhibiting polymorphism. Having given that explanation, maybe we shall go further a bit to understand what we mean. And I'm using some scenarios here. This is an example. And we are saying that the process of actually polymorphism is a process of representing one form in multiple forms and is known as polymorphism. Here, one form represents original form or original method always resides in the base class, and the multiple forms represents overridden methods which reside in the derived classes. This is a technical explanation, and I'm sure all of you are not getting what is the meaning for this. So to demystify this point, what I want you to get is simple. That for polymorphism to occur, there must be classes. That's what I want you first to get from this glance scenario. Don't read everything this here. That for polymorphism to occur, there must be classes. And then in these classes, we should have a superclass, and also we should have sometimes the derived class, or we should have, for example, we can have a parent class, and then we have children classes. Then still, I'm very sure this is very abstract to your mind. You are still wondering, where are we heading to? You have said that polymorphism, an arithmetic operator like addition, can be used to add two different forms of data, whole numbers and also what we call decimal number. Yeah, again, we are saying that that polymorphism, for it to occur, you must always have classes, and indeed those classes, there's something that is going to happen to those classes. I just want to get that level and remain there. Don't just complicate your mind thinking critically. Just get that you should have classes, and also some kind of data can be given to operators that are different, and the operator will give you result. So it's behaving differently to different data, and that also means polymorphism. Then here we are saying polymorphism is derived from a Greek word, two Greek words, polymorphs. The word poly means many, and morphs means forms, so many forms. So that's what we mean by the term polymorphism, although it's derived from Greek, so we can have the meaning. So in the real life situation, you as a human being, you can behave differently at different scenarios. When you are sent to the shop to buy something, you are going there, the shopkeeper will call you a customer. When you are lining up or waiting for a vehicle, if you are using public means, you become a passenger. When you are in school, you are called a student. When you are at home, if the parents are there, they'll call you son or daughter. I'm sure ladies will be complaining, why are you not putting the term daughter here? Never mind, any can do. So what we are saying here is that you exhibit different kind of characteristics, a different scenario. Also, our programs can behave like that. And when they behave like that, they are actually they are showing what we call or displaying what we refer to as polymorphism. Proceed. Now, I want to take this program head-on because if I don't take it head-on, our learners will not understand fully. Our learners will not be able to understand very fully. So allow me to explain what is happening here in this particular program. In this program, we are going to use a class called addition. And this class called addition is the one that is going to show us how is polymorphism occurring. And I want us to, oh, I can see some people are leaving. Please hold on. Today I will give a new concept that are very technical, but I appreciate because you are there and this is showing resilience, which is very good. Now, in this particular program, allow me to proceed by explaining it one bit by bit so that you can get. We have class addition. Kindly note that I had forgotten I'm supposed to have the two very important starting points or statement in this program, whereby I allow the processor directive, channel include, EO stream, then also another point that is supposed to be included above here is what we call using namespace standard. Note that, just know that they are there. Then immediately I have my class addition. Class addition, I'm going to use this class for adding values. I'm going to use this class, this class for adding values. Then immediately I have my class. I go and declare my members on the public sector of that particular class. I declare members on the public sector of that class. Then, and these members, one of them is called void sum. So it is a function called sum. And where I'm declaring this function on the public sector of the class addition is because I want it to communicate with the main function. Then I give this particular sum class parameters. And indeed, I declare two variables which I'm going to be using for communication purposes. In other words, I say on open bracket int A and int B, then I close. So I have a function called sum. Then, before even I proceed to the body, let me come here again. And in the same class, I decide again to have the same function, void sum. Class note here, we have sum here with these parameters, int A and int B. Then again, After closing the body of this function, we have another function with the same name for its sum. Then here we also give it the parameters. We give it parameters. And when we give this parameter, we give it int A, int B, int C. Then we close the bracket and then we open the body of that function. Class, here we are showing certain sign of a certain level of polymorphism. And I want you to get this. Same function with different parameters. Same function with different what? Parameters. The first function has two parameters, int A and B only. The second function, which is the same again, has three parameters, int A, int B, and int C. So this is the same function, but exhibiting different characteristics. One has two parameters or two variables, and the other one has three variables. Let's proceed. Then we close. You can see I've not talked about this. I'll be talking about it as we proceed. Then we close the body of our class. We close the body of our class. So we have one class with the same name but exhibiting different parameters. Then we simply go open into our main function, and in the main function we create an object for addition class. We create an object for addition class. Then that object is called addition obj. And remember, we said sometimes you can simply use one letter, but here we are trying to bring a meaning on this particular object variable which you want to communicate. Then we simply give it, we now link it to the sum, with the sum function in the addition class by saying object.sum. Then we give values, like now in this case we give two values, then 10 and 20. We close. Then we place some space, C out and L. This is a concept of just, it's like you are pressing enter key on the keyboard, just pressing enter key. Then again, we use the same object with the same class, we give it three parameters. So what happens when the program is running? This particular communication will come, then it will check on the parameters. Am I for this one? No. Because I have two values, this one cannot come here. And because it's another function, yes, I have these two functions. So these values will be placed here for the purpose of communication. So we shall have 10 and 20, and then we now compute C out, or A plus B is going to be C out AB. Actually, this is like, this will be added, there will be 10 and actually there will be 10 and 20. So definitely you'll be able to get 30. Then another one is encountered, another communication. Obj.sum with three parameters. Again, it comes with it, checks here, I have three, yes. I think this is where I'm supposed to. So this will be linked to this will be linked to this, and this will be 3. So it will be C out A, which is 10 plus 20 plus 30, and then the end of the day you'll get your 60. So this particular types of polymorphism is called function overloading. In other words, the same function is having different parameters. For example, this one has two parameters is with the same name, and this one has three parameters in the same name. Hence, there is a difference in terms of parameters. Same function, but exhibiting different kind of behavior. And that is what we refer to as in terms of what we call polymorphism. So this is an explanation again. Both functions have the same name with different parameter listing in the same class. Indeed, after I've explained, there are three parameters, and this for communication purposes, they will be linked with this one, and this with two parameters will be linked with that. And that's what we mean by polymorphism, function polymorphism. So basically, this is what during function call, so two parameters will go to this one, and these other three parameters will go to this. At the end of the cell, you will have your 30 and 60. All right. Please, can you tell me whether you have understood anything? Hata kama ni kidogo tu, I really appreciate. To start with again, from the list here, I can see Anne, Kelvin, Erika, Evans, Doreen, Grace, Martin, Matthew, Naresha, Richard, and Vanessa. Kindly confirm whether you have at least understood something small. This is not a joke. This is serious business. But I'm sure you're equal to the task from the way I've been seeing you handling your exams. It is good that we continue like that. Now I have 9 minutes, and I have 9 minutes. I want to talk of the following. Allow me to speak the following now that you are in the house, most of you. It's important. This now is outside. Maybe I want your brain to relax a bit. Ensure that kindly ensure that you do all your cut. If you are able to access the said the S platform, and if you are not done the cuts, kindly do them. For your information, if you don't do the cuts and assignments, and you hope to do the exam, now that the system we are actually using, the system will not grade you. Meaning that you are going to do this unit when it will be offered next. We don't know when. So you can see you have done all this semester, and then you find yourself not actually being graded because you missed your course work. I had sent some messages on WhatsApp, and the following, please confirm. And indeed, if there are numbers, you know them, please let me have them. We have Maina Joseph, Salad Ahmed, Oma Owino, Ahmed Nazim. We have Gifia Akelola. We have Ogamba Mbata. We have Leskov Engandu. We have Eva Magara. We have Anne Calvinia, Irene Omondi, Daniel Wamatuba. We have Pauline Wanchiko, Mohamed Chato. We have Joshua Ibrahim, Edwin Mangi, and Purity Munoe. All the names I've mentioned, they're actually missing 1 or 2 exams on the assignments on the card. So kindly, I would like to have their numbers. If you have them, make sure that I have them. If you have mentioned your name, please see me after the lesson. We sort out this one immediately. Because we don't have another time, remember again, next week you're going to be sitting for your exams. So you might not have any other extra time to rectify this. Remember, this is very important. If you don't have your coursework, you better not even do the exam, because you do the exam again, you will do it again. And remember again, here there is no shortcuts. The marks are in the system, and you cannot complain that you did an assignment when you go to the system and the system is showing you don't have that assignment. So here you have to, we need to be very careful, because we are dealing with systems that are very transparent and very clear. So kindly ensure that if you have not done those exams and your name is appearing here, kindly let us have modality. Exams are there. It's just a matter of activation, and then you do them. And if the class reps are here, kindly let me know the numbers of all these people I've mentioned. Maybe they have been locked out because of the issue of fees. Then we can see the way forward. Finally, your exams will be done this time using remote monitoring, whereby you'll have to have a web camera. So you are not going to do the exam if you are not going to be having a web camera. By that we mean if you are not going to see your image. So we want to confirm, we shall maybe do a rehearsal on this, whether there's anybody with a challenge on that. Because the requirement is that you must log in into video conferencing before you start the exam. And the exam is not going to open until you are actually logged in that video conferencing. So I don't know whether this is very okay. I want to hear the reaction of members before we wind up our class. I know you're heading for another class. But I'm seeking for time. If we can the races, we can also have another session to deliberate on all that. So kindly, can I hear from members before I close? Then, and also there are three PowerPoints that I have not tackled. We have arrays that I've already uploaded in your platform. Keep on reading that particular slide, and in WhatsApp, if you get a challenge, I've tried to actually simplify the concept there. When you read it, you will get it very well. And if you don't understand, allow me to get any feedback on WhatsApp. That's the most fastest way of communication. Anything that you're not following. Then the other part that I'll be uploading today, actually is for some few minutes to come, is what we call the structures and the constructors. There's also information that is well done for you. It's just a matter of reading it and then understanding. It's a very basic actually. It's not something, those terms might look very technical, but it's something so small that you need to understand. So with those few remarks, let me hear your reaction on what I've mentioned, and anything that is touching you, please let us solve it today. Thank you for your time, and now I'm opening for the 3 minutes for any clarification or any concern. Just type. If you have a mic, you can speak to me before we end up our class. So the one I've mentioned, they are missing marks in terms of maybe assignments or cuts. They have not done those in the system. They have not done. And remember again, anything outside the system is null and void. The system is what actually is going to matter this time. Thank you. Can I hear from you briefly? You have 3 minutes. Let me hear from you. Richard, you're typing yes. Okay. Kindly, Anne, Kafija, Kelvin Mokaya, Erica Ojambo, Evans Kimani, Dorina Jeng, Grace Njeri, Martin Siding, Narasha Mekori, Richard Kiveka, and Vanessa Tino. Please confirm to me whether you're fine. Please confirm to me. Okay. Okay, Vanessa, that's okay. Eric, okay. Mokaya, okay. Okay, Doreen, okay. Grace, okay. All right, Evans, okay. Matthew, okay. Matthew's okay. Yes, I'm waiting for Narasha. All right. Now, class, kindly, if you know the numbers for the following students, let me have them. We have Ogamba Mbatha. We have Joseph Maina Joseph, Salad Ahmed, Oma Owino, Ahmed Nazim, Gandu Lestakov, Magara Kefa, Omondi Irene, Daniel Wamatupa, Pauline Wanjiko Kimari, Mohamed Chato, Padoshwa Abraham, Edwin Mwangi, and Purity Munei. If you have those numbers for your friends, kindly, their mobile number, please let me have them in the public chat. If you happen to have them, kindly or you can place them in WhatsApp so that you can know their status. And those who have not done those cards and assignment and you are here, please contact me immediately after the lesson. We see the way forward. Contact me immediately after the lesson. We see the way forward. Okay. So again, if I will need you, be alert on WhatsApp. If I require you to see whether you are able to connect to the web conferencing, I will communicate to you because it's important for you to be able to see how you can connect. Kindly get in touch with me. I will really appreciate. I will be very fine. I will appreciate that. It will help us to. It will help us to be able to. So my number that you can be able to get me 69324 889. That's my number. Most used frequently at the moment. You can get me through that particular number. I believe we are done for today, and I wish you well. I believe that this might be the last time I'm teaching you on this particular lesson on virtual room, and it has been a good thing for me to handle you. You have been very cooperative student. I'm happy for that. And then maybe before I close for you and make assumption, can I hear from one of you or two whether you are really are okay and you really looking forward for a good exam and probably and looking forward for another unit from me? Can I get any feedback before we wind up and I release you to go for another class? Anne, Ulrika, Evans, Doreen, Grace, Martin, Matthew, Richard, and Vanessa. Oh, you have something to say, Richard? Please say something. Okay, you can. If you are using a mic, you can use a mic. Let's confirm very fast, and then we can be able to go to the next class. Let us confirm. You can just type. Okay, Richard, that's good. Thank you. Anne, Erica, Evans, Doreen, Grace, Matthew, your last comment or feedback, and Vanessa. Kindly, I'm waiting for them on the public chat so that we can wind up the class. Okay, it's okay, Anne. All right. Okay, Erica. Okay, Grace. Vanessa, so it's okay. And finally, we have Doreen. Doreen was typing. I don't know. You have something to say? Okay, Doreen. Now, I want to wish you well. Wish you well. Best of luck in your exams that is starting next week. I don't know whether you are starting next week or the week after. And then keep on checking your platform for more information. And if I need you, kindly cooperate. I will tell you to link up and ensure that in WhatsApp you present with me or your official registration number for the purpose of marks processing, which is correct. Names can be the same, but we want to deal with the registration numbers. Thank you. I want to wish you a good morning, and I wish you well in your day endeavors for today. All the best, and let's meet, God willing. Bye for now.